Imagine you're standing at one end of a large room and your friend is at the other end. You whisper something, barely audible to the person standing next to you. But your friend can clearly hear what you said. How amazing this would be, right? Is this possible? What do you think? Well, this magical thing is possible if the ceiling of the room is spherically shaped like an ellipse. This shape, which looks like a stretched circle, is what makes the whispering magic possible. If the ceiling of the room is elliptical in shape, technically semi-elliptical here, then there are two special points in the room where you and your friend can stand. If one of you whispers something, then all the sound waves get reflected from the elliptical ceiling towards the other person. So as the sound waves from one point get reflected and focused onto the other point, your friend can hear your whisper. This works the other way around as well. If your friend whispers something, you will be able to hear clearly as well. Based on this reflective property of ellipse, many rooms called whispering galleries have been constructed. For example, there's one at the Grand Central Terminal in New York City. Isn't this shape interesting? Each of these two special points of the ellipse is referred to as focus. And together, they're called the foci of the ellipse.
All right, guys, we're going to use this graph to kind of fill out the rest of your notebook. So remember the equation of a circle, right? It looks like this. All right, just to kind of refresh your memory, I wanted to know what happens when the radius changes, okay? So from the center of the circle to any point of the circle, what happens when that radius changes? So I'm going to decrease the radius, increase the radius. What's happening to the graph, to the circle? Okay, so as R changes, what can you say is happening to the circle as R is changing? Okay, I'm going to put that back. Okay. The next question is what happens as K changes? Okay, so this with the Y, whatever is with the Y, what happens as K changes? Okay, so look at it. What's going on? As K changes, what is happening to the circle? Okay. The next question is what happens as H changes? So the one attached to the X. What happens as X changes? So keep that in mind. What happens as X changes? Okay. Then it says, given a radius of 6, h is -1 and k is 7, write the equation of the circle. You can do that really quickly. The next one, write the equation of a circle that has a radius of 4 and a center of -2, 3. You can do that as well. You don't need to graph it. We're going to go to the next part of it, which is going to be the equation of an ellipse. All right, so we're going to go ahead and do that. It looks very similar to what we just looked at. So keep in mind that, we're connecting the two. So as we are moving forward, kind of pay attention to it. So this is a circle. We're going on to an equation of an ellipse. All right, so it looks really similar. So take a second just to see what has changed. Okay, what has changed? All right, well, now we have a fraction for sure. So we have that, we have this, and this instead of the radius is 1, right? All right, so what's going to happen to it as M? So now look where M is, right? M is underneath the Y. So what happens as whatever I have underneath the Y changes? What happened? All right, so it becomes a what kind of ellipse? There's a horizontal and a vertical ellipse. Which one would this be? Okay, so what happens as M changes? All right, what happens as the one underneath the X? Okay, the one underneath the X, what happens as that changes? So L, I'm going to put this back. All right, All right, what happens as L changes? Okay, keep in mind this vertical and horizontal ellipses. What happens as L changes? Okay. All right, so now, okay, boom. What happens again when K changes? So it doesn't matter whether it's a horizontal, because look, right? What happens with K? So K is with the Y. So keep that in mind from the circle. What happens as K changes? Doesn't matter if it's a horizontal, and I'm going to put this back, or a vertical. K is going to do what? The exact same thing. So K is with Y. Just keep that in mind. All right. What happens? And I'll just put everything back. As H changes. Okay. So whether it's a vertical or horizontal ellipse, what happens as H changes? So the one with the X. All right, so again, we're just making the connection between a circle and an ellipse. Okay, all right, so now we are on graph the ellipse of that, with the center is 0, 0, okay? All right, so just a few definitions. It says the vertices are negative 6, 0. So here's negative 6, 0 and 6, 0. It says the major axis is 12 units long. So from negative 6 to positive 6, that's 12 units. This is called the major axis. If it is a horizontal ellipse, the longest side is the major axis. All right, then it says the covertices, 0, 2 and 0, negative 2. Notice what those are called. These are covertices, right? So on the major are regular vertices. On the minor, this is minor. So whatever is not the major is the minor. The shorter one is the minor, are the covertices. All right, so now we're going to adjust these equations, and we want to do it so that the graph comes up here. So what am I really changing? Am I changing the x or am I changing the y? Kind of think about that. And I want to get it from 2 to 3. So let's see, what is it that I would need to change to do that? So because I know I'm changing the y, I'm automatically going to start with the y1, and let's see what happens when I change this number. If I make it 2, what happened? Oh, it went down. So instead of making it lower, let's make it higher. Make it 6. Oh, still not there. Make it 7. Still not there. Make it 8. Still not there. All right, make it 9. All right, so there's a relationship between this number right here, 9, and the coordinate 3. So what would I have done to this number in order to get it from, well, what is the relationship, I guess, right now with it being 9 and this being 3? All right, I'll put it back to what it was, which was 2, right? When it was 2, it was 4. Okay, when it's 3, it's 9. So what am I doing each time to the bottom here? All right, and that's the question that you want to ask yourself. All right, so I've made it 3. So now you have the equation of the ellipse. What is the center of the ellipse? So go ahead and write in the center. What are the vertices? So remember, the vertex is the longest. So even though I moved it up to 3, this is still longer with 6. So the vertices are still this, because this is the longer side. So vertices are the longer side, co-vertices are the shorter side. All right, so this is still the longer side. So those are the two vertices. The length of the major axis, so the major is where the vertices are, is 6 plus 6, which is 12. The co-vertices are now 0, 3 and 0, negative 3. The minor axis, so again, now the minor is the shorter axis, the shortest distance from here to here. So this is 3 plus another 3. So that's going to be 6 units. Okay. And don't worry, this is going to make sense in just a second. All right. So let's go ahead and construct this equation for an ellipse. Okay. So we have an equation here. We need to know, is this a vertical or horizontal ellipse? Okay. So I'm just going to bring this back to you. All right. Wherever the biggest number is, that's going to be whether it's horizontal or vertical. So right now, see, the biggest number is under x squared. Let me make this even bigger. Let me make it 49. What happened? Let me make this 81. What happened? It just becomes longer and longer. So that bigger number stretches it out which way? Horizontally. So if the biggest number is over x, it's horizontal. That's how I remember it. All right, I'm just going to put this back, and I don't really remember what it was, so it doesn't matter. All right, now I'm going to make the bigger one y. So y is the smallest one, right? Now let me make the biggest one y. What happened to it? Automatically, it stretched out vertically. So I'm just going to zoom out real quick. I'll make this even bigger. What happened to that now? Again, it keeps stretching out vertically. So if the biggest number is underneath the y, it's a vertical ellipse. If the biggest number is underneath the x, it's a horizontal ellipse. All right. Now, how do I get these numbers? Look at this number. This is 121 and this is 11. So have you figured out the relationship here between 11 and 128? How about 36? So let's see. 6 and 36. Have you figured out the relationship? Because that will tell you what goes up underneath here. Okay. So now you have to answer the question. Given this information, is it vertical, horizontal? So just answer that. How did that change? How did the center? So the center before was, remember the center when we looked at this, I messed it up. But the center, oh, here we go. The center, no matter whether it's vertical, horizontal, was 0, 0, right? All right, so how has the center changed now? So it's moved from 0, 0 to negative 5, 1. How does that relate to these two numbers? And that's what I want you to write there. How does that relate to these two numbers? Okay, so my center was 0, 0. Now it's moved from 0, 0 to x plus 5 and y minus 5. So again, it was 0, 0 because there's nothing here. And now it's moved to plus 5 and minus 1. So how does this new center relate to that? What are the vertices? So you got to know if it's horizontal or vertical. Remember, your vertices are where the longest side is. So this will be horizontal and this will be vertical. So if it's longest this way, your vertices are here and here. If it's longest this way, then your vertices are here and here. And then the co-vertices are on the shorter axis. So you can have a vertical one, and so your vertices will be here, here, and then co-vertices will be here, here. You can have a horizontal one, so your main vertices are here and here, and your co-vertices are here and here. So just depending on what it is, if it's a horizontal ellipse or a vertical ellipse. All right, what is the length of the major? So remember, just like we did the previous question. All right, and I've changed the numbers and it's fine. So this is a vertical ellipse, right? So the biggest number is over the y squared. All right, this length is 11 plus this other 11. So 11 to here, 11 to here. And notice what is that relationship, right? So it's 2 times the radius, or 2 times whatever the square root of 121 is. And then what is the length of the minor axis, the shorter axis? This one, it goes from 6 and then another 6. So 6 plus 6, and this is going to be 2 times whatever the shorter square root of 36 is. So 2 times square root of 36. Okay, and that